The next question deals with equilibrium in the human body. Find the force exerted by the bicep muscles in holding a 1-liter milk carton with the forearm parallel to the floor. Assume the hand is 35 centimeters from the elbow and the upper arm is 30 centimeters long. The elbow is bent at a right angle and one tendon of the bicep is attached to the position 5 centimeters from below the elbow and the other is attached 30 centimeters from the elbow. The weight of the forearm and the empty hand is 18 newtons and the center of gravity at a distance is at the distance of 16.5 centimeters from the elbow. So now in this case, it says the force is exerted by the biceps. So I'm just going to draw another picture that's hopefully going to be a free body diagram for this case. So here's where the milk carton is. Here's where the hand is. Here's where the elbow is. And it says that there's one muscle that goes up here. I'm going to call it the bicep muscle, FB, for a lack of a better word, maybe capital B. And then it says that the center of mass for this system is going to be somewhere here, and its weight is going to be acting downwards. So let's say I'm going to call this weight of the center of mass, and I'm going to call this weight of milk, right? And so this is what I'm going to start off with. And what it's asking me is that find the force that this muscle has to apply. Well, so technically I cannot take my hinge to be located at this position. So what I'm going to do is I'm just going to call this one as my hinge position and write sigma torques. So my sigma torques are going to be due to FB. It is going to be due to the center of mass. I'm just going to call it torque due to the center of mass and torque due to milk. So these are the three basic forces, these basic torques that are going to be introduced into the system. Now what about plus and minus? Well, this is the force that's going up, so this is going to cause a positive torque. This is going to cause a negative torque, and this is going to cause another negative torque. System is not going anywhere, so this becomes equals to 0. What do I get? I get 0 equals force of the system, and I'm just going to rearrange it so that it becomes torque due to the center of mass plus torque due to milk. Now the next question is going back to what we know. We know this is going to be R due to the bicep muscle times F due to the bicep muscle equals torque due to the center of mass, this going downwards, and this is going to be R center of mass times F center of mass plus R milk times F milk, right? Okay, now that we have all of this information, all I have to do is, in order to calculate what FB is, I have to calculate what R center of mass is. They tell me it is at 16 point R center of mass. It's given to be 16.5 centimeters, so I need to convert it to meters, which makes it to be 0.165 meters time. What is the force that's acting on it? It is going to be 18 newtons, because that's what it's giving me, plus R for the milk is the complete one, 0.35 meters. And F for the milk is 1 liter, so 1 liter equals 1 kilogram. That means for my force of the milk is going to be 1 kilogram times 9.8 meters per second divided by R of this little tiny distance, which was given to be 5 centimeters long, which means I have to divide it by 0.05 meters. Plug it into your calculator, solve for it, and I calculated it to be that. So please make sure you calculate it for yourself and you actually understand what we are doing in all of these scenarios. These are not difficult questions, but it only requires a lot of practice.